So, oh. Why didn't you say something? All right. So, if you see something like this, which you will, if you see something like 3 square root of 5 times the square root of 6 times the square root of 6 times the square root of 6. Uh-oh. Moby's having problems today. Let's try that again. Okay. Times the square root of 6 minus the square root of 7. You just use the distributive property. Okay? So when you multiply radicals together, you have to multiply this times this and this times this, right? So what's 3 root of 5 times root of 6? You don't have to do this one on your whiteboard. This is more like notes. What do I do with those things inside the square root sign? Multiply them. What's 5 times 6? 30. So you get 3 root of 30 minus 3 root of what? 3 root of 35. Okay? And that's all there is to that. Okay? Not super complicated, right? Can you do that? Okay, so what's wrong?
So you don't subtract the 30 and...
No, you can't, unless these are the same thing inside the square root, you can't mush them together. If they were like root 5 and root 5, then I could put them together. But if they're different things underneath the radical, you can't combine. Okay, so here you go. Your turn. You ready? Set.
You try.
You try. You try. We'll get through these pretty quick. 2 root of 3 times 6 root of 5 plus root of 10. Okay? Equals. Almost the same type of problem. Yes. Is that right? I'll tell you if it's right or not. Yes, that's right. Plus sign in between. Plus sign. Plus sign. Yes, that's right. 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 And at the very good box. Yes, that's right. No. Wait, I didn't see anyone's back there. Where's Chase's? Chase, where's yours? Where? Wait. You didn't multiply the 2 and the 6 together. Okay, that's right, that's right, that's right. Yes, that's right, Andres. That's correct, Sophie. Chase, did I saw it. No, I didn't. That's right, Calvin. Okay, so most of you got that correct. You should have gotten 12 root of 15, right? Plus 2 root of 30. Yes? Easy enough. Yes? So the next type of thing that you're going to see is it involves foiling. Okay? So if you were to see something like this, 4 root of 5, 4 root of 5, no math cheer here, minus 3 root of 2, that's part of the math cheer, 3 root of 2 times 2 root of 5. Don't write this on your whiteboard. I'm going to do it with you, okay? But I'm going to give you a chance to try, okay? 4 root of 2, okay? This is what happens in this one, okay? So remember FOIL. First, outer, inner, last. So you do it just like you're foiling x minus 3 times x plus 2 or something like that. So I have to multiply my 2 first terms here. What does that give you? 8 root of what? 25, which can be simplified, but we'll worry about that later. Okay? What do the 2 outer terms give you? These are the 2 outer terms. Multiply. 16 root of 10. What do the 2 inner terms give you? negative 6 root of 10, right? What do the two last terms give you?
Negative 12.
Negative 12, negative plus negative 12. So I'm going to turn this into a minus, okay? So minus 12 root of 4. Then you could do some simplification. What's the square root of 25? 5. So what's 8 times 5? 40. So you get a 40 over here. You can combine these two like terms. How many roots of 10 do I have altogether? 10 root of 10. And what does this simplify to over here? 12 times 2, right? This is 12 times 2. Yes? Which makes negative 24. And then I can do some more combining here. 40 minus 24 is how much? 6, so you get 16 plus 10 root of 10. And that would be your, is that your final answer? That's your final answer. Did you follow the steps? So that can get a little bit tricky. So let's try one similar to that. Okay. So how about a try? You try. You try. Okay. You try 3 root of 7 plus 2 root of 3 times 4 root of 7. 4 root of 7 minus 6 root of 3. Go ahead. Give that one a try. I just made that one. Let's see what it comes up to. Because the one for my viewing audience. So if you didn't get this, you multiply the 3 times the 4, that makes 12. I kind of did some of this in my head. I know that root of 7 times root of 7 is what? Is 7. So I know that 12 times 7. So I get 12 times 7 is my first term. Okay? My outer term is 3 times root of 7 minus 6 times root of 7, or root of 3, which gives you negative 18 root of 21, right? My two inner terms, right? 2 root of 3 times 4 root of 7 gives you plus 6 root of 21. And my two last terms give you minus 12 times 3, right? Minus 12 times 3. And that makes 84 minus 36, which makes 48. And negative 18 plus 6 makes negative 10 root of 21. That would be your final answer. What did I do wrong?
Yeah, it's 8, not 6.
Where's 8, not 6?
It's negative 18.
On the
This should be 8.
Yeah.
I knew that. I did it right on my homework. I just was, sometimes it's hard for me to think and talk at the same time. So that is, that's 8 root of 20. Thank you, Caleb. All right, so there's more, okay? But I'm just going to do a couple more problems. So say you were to see, I want you to try this one. See what happens if I multiply square root of 3x minus square root of 2, okay, times square root of 3x plus square root of 2. Okay? You try. I want you guys to try. Try this. So, you guys, first of all, if you multiply these out, most of you found that the first term gives you the square root of 9x squared, right? And the last term gives you the square root of 4, right? Hey, you guys, come on. The outer term gives you outer term gives you root of 3x times root of 2, which is positive root of 6x. And the inner term gives you what? Negative root of 6x. But what happens here is these things go away, right? Okay? And what is the square root of 9x squared? 3x. 3x. And what is the square root of 4? 2. Oh, there's a minus sign in front of you, right? Because it's minus root of 2 times plus minus 2. So that's kind of neat because it makes all the square roots go away, okay? And these things have a name. These are called rational, not rational. They're called conjugates. Complex conjugates? They are called conjugates, yeah, just conjugates. Conjugates, and we talked about this, conjugates. Remember when we did a plus b times a minus b, right? The middle terms disappear. So if one is plus and one is minus, the middle terms disappear. But what's nice about radicals, if these are both radicals, not only does it make the middle terms disappear, but it also makes the square root signs disappear, okay, which is kind of nice sometimes. And that leads to the next thing, which is called rationalizing the denominator, okay? And this is kind of the last thing I'm going to teach you, okay, today, and then you'll have that worksheet to practice on, okay? So this is called rationalizing. We've already rationalized denominators with just a simple square root denominator in the bottom, okay? But if you see something like this, 4 plus, what's going on back there, okay? 4 over 5 plus square root of 3. The way you rationalize the denominator is by multiplying by the conjugate of the bottom, okay? So on the top and the bottom, because basically I'm just multiplying by 1. So what is the conjugate of the bottom? What's the What's the opposite of 5? Not the opposite, but the conjugate of 5 plus root of 3. Adam?
5
Yeah, or 5 minus root of 3, okay? So this, I'm going to multiply this, whoops, where'd my root of 3 go? 5 minus root of 3 times 5 plus root of 3. If I multiply the bottom by that, what do I have to multiply the top by? Same thing, right? Because really what I'm doing is I'm multiplying by 1, right? Okay? When I FOIL this bottom, I get 25, that's the first term. Outer term is minus 3 root 5. The inner term is plus 3 root 5. And the last term is what? What do the last terms give me? Plain old negative 3, because it's plus times minus 3, okay? So on the this is my bottom. This is going to go away. What's 25 minus 3? 22, right? Okay? So that's what my denominator is going to look like when I multiply by the conjugate. Okay? What's my numerator going to look like? What's 4 times 5? 20. What's 4 times negative root of 3? 4 times negative root of 3. What? No, it's just negative 4 root of 3. You can't multiply, if this is outside the box, so I have to multiply this times this, and I have to multiply this times this. But I can't multiply something inside the box by something outside the box, so I have to leave that outside the box. You can reduce this by a factor of 2. How many times does 2 go into 20? 10 times. How many times does 2 go into 4? 2. How many times does 2 go into 22? 11. This is your best answer, okay? Because this is okay, but this is in reduced form. Because you can divide, if you can divide everything by a number, that's how it works, okay? So this is your last U-try. Okay? Putrid. Putrid. There we go. So this one is going to look a little bit different when you get done, but this is a good try. So rationalize. 12. No, that's wrong. I wrote that down wrong. 2 plus root of 5 over 6 minus, I wrote root of 3. Let's do it that way. 6 minus root of 3. 2 plus root of 3 over 6 minus root of 3. It's okay? Well, this is a toughie. So what you need to do is multiply the top and the bottom by what? You should know that. What should I multiply the top and the bottom by? 6 plus root of 3, right? And, right, that's called the conjugates. So you have to multiply the top and the bottom by the same thing. On the bottom, I can kind of do this in my head because I know that the middle terms are going to disappear when I multiply by the conjugate. So on the bottom, I get 6 times 6, which is what? 36 minus root of 3 times root of 3, which is what? 3. Okay? On the top, I actually have to FOIL it out. So I go 2 times 6. First term gives you 12. The outer term gives you plus 2 root 3. The inner term gives you plus 6 root 3. And the last term gives you root of 3 times root of 3, which is what? 3, right? And then you simplify. So 12 and 3 makes 18. 2 root of 3 plus 6 root of 3, that doesn't make 18, it makes 15, right? 2 root of 3 plus 6 root of 3 makes what? 8 root of 3. 8 root of 3. And 36 minus 3 gives you 33, okay? And that's your final answer. You cannot reduce this. If 3 went into all of these, then you could reduce it, but it doesn't. I saw some of you trying to reduce this. That's as far as you could take it, okay? If you could, if like 5 went into everything here, then you could reduce it, but that's as far as you could go, okay? So, so that's how it goes. I'm going to stop here and